So what we have learned till now is that delta L can be written as PL by AE. This is an extension of Hooke's law, where P is the applied load, L is the length of the member, A is the cross-sectional area, E is the Young's modulus. The units of everything are known to you. P is in Newton, L is in mm or meter, A has to be of the same unit of A, L has to be of the same unit of A. If L is in then A will be square, and E has to be written as Newton per square only. So LAE have to be converted to the same unit in case you want to use them. So bars in series means that let us have a situation where we have uh, these bar, bar of this type, let us say, and it is subjected to a 10 kilonewton force. Let us say this length is 0.6 meters, this is 1 meter, and this is again 2 meters. If I say phi is 50 and here phi is 25. So writing down phi means the question is you need to find out total delta L. So writing down phi means that phi is a engineering specification of diameter. So phi is equal to 50 actually means that the dia is 50 mm, and the unit is also specified that it will be only. ठीक है? Is never written. So if it is nothing is mentioned, then it automatically means that it will be So if you are asked to assume, then it has to be in only. So let this section be 1, let this section be 2, and let this section be 3. So delta L total will be equal to delta L of 1 plus delta L of 2 plus delta L of 3. So delta L of 1, it will be acted upon by the same load. So this is 10 into 10 to the power 3. PL, L is 0.6 meters, so it is 600 by AE, it is pi by 4 into 50 square, and whatever value of E is given, you can use it. If I write down delta L2 is given by 4PL by pi E d1 d2. This we have derived in the previous lecture. So this is 4 into 10 into 10 to the power 3 divided by length is 1 meter. So this is 1000 divided by pi into E will be given to you the dimensions. The dimensions D1 and D2. So D1 and D2 means the element starts at 50 diameter and finishes at 25 diameter. So you have both the dimensions of the tapered bar. And similarly, you can calculate delta L3. This will be again given by PL by AE. So this is 10 into 10 to the power 3 multiplied by, this is 2 meters. So this is 2000 divided by AE. So this is pi by 4 into 25 whole square multiplied by E. So you individually calculate the values of all these three elongations and sum them up so as to find out the total change in length. So now the next thing, or the next concept that comes into picture is principle of superposition. So principle of superposition is a specific type of case of bars in series where you see that let us say you have this bar and you have different forces acting on it at different locations. So let us say this is 100. Let it be Newton, kilonewton, whatever it is, we'll see later on. This is 150 and this is 200, and this be P, some value P. Let us also mention the dimensions. This is zero point 0.6 meters, this is zero point 0.8 meters, and again this is zero point 0.6 meters. Let these members be known as A, B, C, D. So this is a specific case where bars have been connected in series and they are subjected to different normal loads, not tangential loads. They are subjected to different normal loads at different locations. Now, where do we see this type of load? This type of load is generally visible in cranes where you have different members being connected together and they are subjected to different loads depending upon the weight it is lifting and the inclination at which these different members are. Second type of example is chassis. On a single chassis, we have different uh, bolts or different loads being acted at different locations. Like if the engine is mounted on the chassis, it carries a other load. Other than the engine, you have a radiator which is mounted separately, so that subjects it to a different type of load. Moreover, you have battery installations which are separate again. You may have the transmission system also resting on it. You may have the suspension system also resting on it at different locations. So the engine load is exactly at the middle. You have suspension load at the ends. You have radiator load at the other end, and you have foundation bolts, uh, which is where, with the help of which, you are tightening the chassis to the car frame. So you have different loads acting on the body at different locations, but you need to keep in mind that this is a single component. A chassis is a single component. You do not manufacture it in pieces. So this is a single component which is subjected to different loads at different locations. So when you have problems like this, these are solved by using principle of superposition. So principle of superposition says that sum of forces in one direction is equal to sum of forces in another. If this condition is not satisfied, principle of superposition will not work. So for equilibrium of the structure, or for uh, making the problem to be solvable, the sum of forces in one direction has to be equal to sum of forces in another direction. So if you look at this problem, you have 100 plus 150 plus 200. This is equal to P. Sum of forces in one direction is equal to sum of forces in another. So this is 350 and this is 100. This is P is 450. Let it be Newton. Now you need to solve this. So the problem is you need to find out total delta L. Here also you need to find out the total delta L. Total delta L, if this is section 1, this is section 2, and this is section 3. You can see that on section 1 you have 100 on one end and 450 on the other end. On section 2 you have 450 on one end and 150 on the other end. So there are mismatch of forces. So you need to balance these forces so that they can be appropriately used. So to balance these forces, what we do is we select whether we'll be moving from left to right or right to left. So let us say that as customary, we'll be solving the problem from left to right. So to solve the problem from left to right, what you do is you isolate AB. If you isolate AB from the system, this is 100 and this is 450. This is the location of forces if you isolate AB. So once you have isolated AB, what do you get? This is 100, this is 450. You are moving from left to right, so the left value of force is called as your reference and the right value is called as your manipulator. The right one is called as your manipulator. So to manipulate it, what you are doing is, let us add 100 to it, and let us subtract 100 from it. ठीक है, let us add 100 and subtract 100. So if you add 100 and subtract 100, again if you use this principle of superposition here, the principle of superposition stands true. जैसा पहले था, अब इसमें 100 दोनों तरफ जोड़ दो, क्या फर्क पड़ेगा, तभी भी प्रिंसिपल ऑफ सुपरपोजिशन रह गया. अब आपको क्या करना है कि अब आप इसको यूज करिए अलग तरीके. आपको चाहिए कैसे था, रेफरेंस ये 100 है, तो आपको यहां पे चाहिए था 100. सो दिस फोर्स and this force have been used here. So your AB part is complete. क्योंकि आपको चाहिए ऐसा, अगर ऐसा नहीं होगा, so then you cannot apply the formula of delta L. So delta L अप्लाई करने के लिए आपने क्या किया, 100 ऐड किया, 100 घटा दिया, तो ये आपका फिगर ऐसा हो गया. अब ये हो गया एक हिस्सा. आ जाइए दूसरे हिस्से पे. दूसरे हिस्से पे आएंगे, लेट अस से BC. So if you come to BC, so here this 100 has been used, so you have 450 here and 100 here is actually 350 here. 450 in this direction, ये 100 तो यहाँ यूज हो गया. 450 in this direction and 100 in this direction is actually 350 in this direction. और दूसरी तरफ है आपका 150. Okay, so again this is your reference and this is your manipulator. So if this is your reference, what you do, you add 350 and you subtract 350. Again principle of superposition will hold good. So draw the final diagram. So this is BC. You have 350 here. लेफ्ट वाले के रेफरेंस को ले यूज करके राइट हैंड साइड में जो जो चेंजेस करने हैं सब राइट हैंड साइड में करेंगे, क्योंकि हम प्रॉब्लम को लेफ्ट टू राइट सॉल्व कर रहे हैं. अब ये हो गया, ये 350 और ये 350 यूज हो गया, तो छोड़ के क्या गया, 150 इधर और 350 इधर. सो ये आपका 350 यहाँ यूज हो गया. नाउ कम टू द थर्ड पोर्शन. सो इफ यू कम टू द थर्ड पोर्शन, व्हाट इज लेफ्ट विथ यू. देखो ये यूज हो गया, 350 इधर और 150 इधर, का मतलब होता है 200 इधर, और तीसरा हो गया आपका 200 इधर. सो तीसरा पार्ट जो है वो आपका खुद ब खुद बैलेंस होगा. अगर ये नहीं हो रहा है तो इसका मतलब आपसे गलती हो चुकी है. सो अब आपको टोटल डेल्टा एल निकालना है. सो टोटल डेल्टा एल क्या होगा, इट इज डेल्टा एल ऑफ, टोटल डेल्टा एल इज डेल्टा एल ऑफ ए बी plus delta L of BC plus delta L of CD. So for delta L of AB, you will use P is equal to 100, but this P will be, this delta L will be negative. Why it is negative? Because this is compressive load. Here it is compressive. Here this is tensile, and this is also tensile. So tensile is positive, compressive is negative. So this actually becomes minus delta L AB plus delta L BC plus delta L CD. दूसरा डेल्टा एल BC के लिए क्या होगा, P आपका होगा 350, और डेल्टा एल CD के लिए आपका P होगा 250. ठीक है, लेंथ आपको गिवन ही है. अगर इनका क्रॉस सेक्शनल एरिया है तो इनका डायमीटर या फिर एरिया गिवन होगा, और E की वैल्यू गिवन होगी. यूज देम एंड कैलकुलेट द टोटल चेंज इन लेंथ फॉर दिस बार सब्जेक्टेड टू डिफरेंट टाइप्स ऑफ लोडिंग. So let us solve this problem moving from right to left. So when we are moving from right to left, obviously we need to again isolate our systems. So the first system will be CD. So the purpose of doing it is to show you that whether you solve the problem from left to right or right to left, you will get the same magnitude of forces acting at every sections, as well as the same value of delta L. So while moving from right to left, the first portion that comes into place is this is 200 and this is 150. So when you are moving from right to left, the right portion becomes your reference, the left portion becomes your manipulator. So what you do is you add 200 and you subtract 200. So when you add and subtract 200, you get the final figure here as this is 200 and this is 200. So this and this have been utilized. This one. Now coming to the other section. The other section is BC. If you look at BC, 150 is here, 200 is here, so you have 350 here. If you have 350 here, this P is already you have calculated this as 450. So again, this is your reference and this is your manipulator. So what you do is your reference and manipulator you need not write in your examination. This I am showing it you for practice only. Okay. So here you have 350 and what you do is you add 350 and you subtract 350. So this 350 and this 350 are used up. And what is left is section AB. What is left is section AB. So AB, this 350 has been used, 450 is here, 350 is here. So you have 350 in this direction. You have 100 in this direction, 450 here, and this has been used, 350 here is 100 in this direction. You have 100 in this direction, which is preloaded. This is A and B. This is automatically balanced within itself. Total delta L, again you can calculate delta L AB. This will be negative because it is compressive, plus delta L BC plus delta L CD. So irrespective of whether you solve it from left to right or right to left, you will get the same answers, and you need to be very cautious while calculating the equivalent forces in sections. So once you have calculated the equivalent forces in sections, you can apply PL by AE and calculate the change in length for any specific section.